viscosity, right? So I can tell, my dear, viscosity as a property of fluids. What is student? In this lecture, I'll discuss about viscosity, right? So students, I can say viscosity is a property of fluid, right? The property of a fluid due to which it opposes the relative motions between its different layers called viscosity. Viscosity beta, you can also tell that is the fluid friction or you can say internal forces. What my dear? Viscosity, you can also tell fluid friction or what my dear internal forces. The force between the layers opposing the relative motions is called viscous force. What my dear? The force between the force, what my dear? The force between the layers opposing the relative motions is defined as what my dear? That is what viscous force. Now, students, these entire things are explained by the help of diagram as well. Students, consider a liquid flowing at a steady rate on a horizontal surface. The liquid may assumed to consist of different horizontal layers. How should let try to understand here by student. Now I'm going to explain you with the help of example. So, my dear, here let us suppose I'm going to discuss, my dear, in detail. That is visco. That is what, my dear? Viscosity. This is what, my dear? Viscosity. Okay. So viscosity beta, you can also tell fluid friction, my dear, or you can tell also, my dear, that is what internal force. That is what, my dear? Internal force. So student, let us first I want to write here few basic definition, my dear. Beta, I wanted to write basic definition of viscosity, which I read, I can say fluid mechanics of in engineering, third semester, my dear. Third semester or fourth semester, my maybe fourth semester, which okay. So beta here, what can you say? Viscosity is what? Viscosity, student, viscosity is a beta property property of fluid. This is what, my dear? First point here, viscosity is a property of fluid. Okay, fine. Now, students, I can say next point here, what you can keep in your mind. The property of a fluid due to which, student, next point you can keep in your mind. The student, the property, the property, the property of a fluid, the property of student fluid due to which student it opposes, my dear, it opposes the the relative motion, my dear, relative motion, relative motion between its different layer, between its different layers is called my dear, it's called viscosity. It's called viscosity. Beta, sometime you can find viscosity beta. You will see somewhere viscosity. You can also say fluid friction or beta. You can also tell that is what, my dear. You can say internal forces. Student, either you can say fluid friction or beta. Somewhere you can get that is what this is also known as, my dear. That is a internal forces. Okay. Beta, one more thing here I wanted to add over here. Then, beta, I'll start explanation. Entire explanation, beta, that is what in detail, right? The force, student, the force between the layers, between the layers opposing, between the layer opposing the, opposing the, my dear, relative motion, opposing the beta, this is relative motion is called, is called as, it's called as beta the viscous force. Okay, now students, I'm going to discuss this entire thing behalf of, I can say, mathematics you can tell, right? So beta, as I said, consider a liquid. Let us suppose students, I'm considering, students here, I'm considering there is what you can say, this is bank of river. What, my dear? This is because a bank of river. This is not, I'm talking about PNV and like SBI, because this is what I said, bank of the river, right? Okay. So now, beta, consider liquid flowing at a what? Liquid, beta, because this is the bank of the river. This is the bank of the river, beta. You can see inside the river. This is water is flowing, beta, regularly. Water is today flowing, right? Okay. So what's the condition, beta, which I wanted to connect here behalf of viscosity, right? Yes, beta. Just as you can say river, inside there is what? Water is flowing. Okay. Yes, beta. So what I'm telling, consider a liquid flowing at a steady rate on a horizontal surface. The liquid may be assumed to consist of a different horizontal layers, right? Okay. Now, beta, if a specific layer of a liquid is considered, let us suppose, you can tell it as an example. Students, I'm considering this point. Student, I'm considering this, let us suppose, this particular reason. I wanted to do study for this reasons only, right, my dear? Okay, so beta, if a specific layer of a liquid is considered, right, the layer below it tries to decrease the velocity of upper layer due to cohesive force between the molecules of the adjacent layer. Student, what I'm telling you, beta, you can say this is beta. If you are, I can say this is top level of river, right? So beta, top level of river, beta, there is what you can think velocity is very high, velocity is very high, right? But beta, because this is the fluid, this is what flowing. I can say there is neighboring fluid tries to what decrease the velocity. Neighboring fluid beta what it tries to decrease the velocity. Neighboring fluid which says what tries to decrease the velocity. So beta, how can we just take consideration? Beta, this is you can see topmost point velocity is maximum, my dear. So neighboring fluid beta tries to decrease the velocity due to what, my dear? Cohesive force. I hope all of you know cohesive force. Cohesive force act between what? Same layer of the liquid. You can say water, water. You can say kerosene oil, which right, my dear? Okay. Next, students, I can say this is the conditions beta. You can analyze. This is what velocity continuously decreasing. Students, you can take like consideration. Velocity is what? Continuously decreasing. Velocity is what, my dear? Continuously decreasing. Due to what? Cohesive force. Because if what you can see, this is what? Due to cohesive force. Beta, you can see finally, you can see beta finally, this is what velocity goes to what? Zero. Beta, if what? It will go finally bank of the river. So beta, this point, what you can say, velocity goes to zero beta, bank of the river. And beta, what you can say at midpoint of the river, that is what velocity is maximum. Velocity is maximum. So beta, again, I am repeating my own word. If a specific layer of a liquid is considered, the layer below it tries to decrease the velocity. Layer below it tries to decrease the velocity due to cohesive force between the molecules of the adjacent layer. Beta, what you can say, this is what adjacent layer. In turn, you can say upper layer moving with what? As you know, bacha, upper layer is what? Moving with greater velocity. And beta tries to what? Increase the velocity of lower layer, right? Thus, an opposing force comes into play. Beta, I know this is the layer beta, velocity is maximum here. So this velocity means this layer of the fluid try to what? Increase the velocity of what? Lower layer. So beta, due to what you can see, thus an opposing force comes into play. What bacha? Thus an opposing force come into play. So beta, due to this, what you can say bacha party, this force is what? It's nothing but already I said this is what known as viscous force. This is what known, my dear, viscous force, right? So bacha party, you can also think like that. It appears in what tangential shearing force is acting between the layers to overcome these shearing forces and maintain constant velocity and constant velocity maintain beta ji constant velocity maintain bachcha ji constant velocity, right? So beta, for this condition what you can say, shearing force to maintain constant velocity between what adjacent layer. Shearing force beta what to maintain constant velocity, what you can think bachcha, these all are theory points which I'm taking regularly bachcha. They can frame questions, multiple questions based on this bachcha ji, right? So beta ji, what you can say, adjacent layer and external force is applied to it. If there is no any external force, then velocity of the fluid decreases and finally what becomes zero. Because beta, finally this is a layer of the fluid tries to what increase the velocity of lower layer. But beta, because there is no any external force, there is no any external force. So what you can say, velocity of fluid decreases and finally what becomes zero at the what bank of the river. What bacha see? Jai Shri Ram, student. Beta, what I can say, velocity initially increases bacha, but in this velocity top layer try to increase the velocity of another one bacha party. So finally, you can say there is no any external force. So what you can say, final velocity becomes zero. What was the velocity becomes zero? In case of a steady flow of a fluid, when a layer of fluid slips or tends to slip, because no, there is water fluids each other here. So what you can say, there are two layer of fluids. What slips or tends to slip, just slips or beta tends to slip on adjacent layer in a contact, right? The two layer tangential forces act on each other, which tries to what destroy the relative motion. Because bacha, tangential force is there with what which tries to beta. These all things already I discussed in fluid statics. What is the tangential forces and all. So bacha party in this condition, what you can say, this tangential force tries to destroy relative motion between them. The property of a fluid due to which it opposes relative motions between the different layers is called viscosity. What, my dear? Viscosity. Already I said these all points. Now, bacha, this is the I can say explanation entirely for what I can see viscosity. Now, students, I'm going to conclude entire point with the help of mathematics. So, beta, what can I write? What can I write? Beta, I can say this according to observations. Beta, what I can say according to observations. Now, beta ji, I can say this is what viscous force, bacha. This is what viscous force, what directly proportional to this is what you can say area. This is what bacha, you can say what area. So, beta, these all things here. I'm going to conclude according to Newton's hypothesis, beta, because this is mentioned here. Why I'm writing? Because these all points mentioned in your textbook as well. So, according to beta, according to this is Newton's Hypothesis. According to beta Newton's hypothesis, force is what? Directly proportional to A. A is what? Area of cross section. A is what, my dear? Area of cross section. But I know what is the things. Already I said, my dear. Beta velocity increases, right? But let us suppose this entire distance you can take y. You can take bacha what? This is what? By. So with respect to this distance, with respect to this distance, bacha, what you can take my what you can say, my dear, velocity is what? Velocity what? Decreases continuously, bacha. According to distance, either you are going to move in this directions, or a student, if you are moving in this direction, beta, these two directions, what velocity is what? Decreases. So this is, students, you can again write here as per your observation. Force is directly proportional to what? This is dv upon dy. And this is what, my dear? It's nothing but you can tell a student this is beta velocity gradient. This is what, my dear? Velocity gradient. Gradient beta you can easily use. It's a literally J already asked multiple times. Something per unit length beta. You can say gradient. Something per unit volume. You can say density. You can say like you can say what is the energy density? So energy per unit volume. So what is the velocity gradient? Velocity per unit length, my dear. Okay, very nice. So F is what was that? Directly proportional to dv upon dy. Okay, beta one thing here, which we can say, beta, you know, if we are getting some proportional sign, student, if you are getting some proportional sign, so we have to remove, student, we have to remove and use what? Some suitable constant. So we can say, which this is what F is equals to minus. This is what? Eta A. This is what, my dear? dv upon dy. This is what, my dear? This is dv upon dy. Now, beta, what is the meaning? Because this directly, beta, one time they already asked in PYQs. Student, they asked beta one time directly formula only. What is the viscous force? I can say among the layer of fluids. So this is beta already asking beta what I can say P by Q, previous by year questions, right? Expression of viscous force in the fluid. So F is equals to minus eta A dV by dy. Then you can ask what is A? A is what was a party? Area of cross section. My dear, A is what? Area of cross section. Eta is what was a party? Coefficient of viscosity. Eta is what, my dear? Coefficient of viscosity. Now you can say dV upon dy is what? Velocity gradient. Already I said. Now, bacha, what is the meaning of negative sign here? This is the question. What is the meaning of a negative sign? It's nothing but you can say negative sign is implied. What's the meaning of this? Because viscous force acts in a what? Direction opposite to flow of liquid. Because this is what's meaning implied with viscous force acting between layer of fluids in what? Opposite directions of motion of fluids. So what's representing? This is what you can see finally, direction of viscous force. Let us suppose if your liquid motions towards this direction, so viscous force acting in this direction. Viscous force acting, my dear, this direction. So students, this is, I can say, this is all about entire explanation of viscosity. This is what, my dear, entire explanation of viscosity. Keep in your mind, what is the meaning of minus sign? Viscous force act in a direction opposite to the flow of liquid. So this is student keep in your mind about what is the meaning of minus sign. F is equals to eta A dV upon dy. Student, I'll upload this video, this lecture live stream as usual on YouTube. Anywhere you can watch. Anywhere, anytime, beta, you can watch. Okay, now bacha party, have a look next. So this is what I can say entire discussion about viscosity. I hope you enjoying the session of physics point live streaming. Now, bacha, let us suppose you can take as a consideration. Beta, let us suppose as a consideration if if A is equals to 1. God bless you, dear, for your reaction. dV upon dy. Beta, I'm considering here what? 1. Then beta, what you can say? Simply, you can say, bacha, just put all the values beta in the equation of force. F is equals to minus eta A dv upon dy. This is the beta g what? 1. This is on the chart. So you can say F is equals to eta. Minus beta, I'm not considering over here because minus is what direction of viscous fluid, which is what opposite to flow of motion of liquid. Okay. Now, the I can say hence coefficient of viscosity is defined as the viscous force acting per unit area between two layers are moving with a unit velocity gradient. Bacha. This is the point beta which you can keep in your mind. Okay, let's talk about beta. Let us I can say basic point. This is what, my dear. What is the SI unit? What is SI unit of beta G viscosity? What is SI unit? Bacha, what we can say? Viscosity. So, bacha ji, this thing here, I wanted to just write once beta because no, beta they ask multiple time. Students, they ask multiple time, bacha, that is, you can say what is the SI unit of viscosity? What is the dimensional formula of viscosity? So, beta, I'll write here both of the things. My dear, I'll write bacha party both of the things, right? Okay. So, beta, come to the point. Beta, we wish to find viscosity SI unit. Beta, if we wish to find any of the unit, so beta, try to separate those quantity which you wanted to find unit. So, student, you want to find what? You wanted to find coefficient of viscosity unit. So, beta, this thing you have to remove from crowd. So, you can write beta. Just I'll use beta equation number one, beta, as usual, my dear. This is A dv upon dy. Just do beta cross multiply. F into dy upon beta A into dv, which is equals to coefficient of viscosity. Now, bacha, this is, I can say, bacha, this is finally what? Separated coefficient of viscosity from crowd. I hope all of you remember what is the SI unit of force, which is nothing but Newton, bacha. Dy is nothing but it's a, we can say, with a distance. So what's the unit, bacha? This is, you can say, meter. Beta, what is the area unit here? This is, you can write meter square. What is the velocity unit, my dear? This is meter per second. So beta, I can say second goes up. This is nothing but coefficient of viscosity. Now, students, you can say, sir, this meter finished. You correct, beta. Now, students, you can say, what is the SI unit of coefficient of viscosity? So, you can write Newton second per meter square. Newton second per meter square. But rarely, beta, you will get this expression. Student, rarely you will get this expression, right? So, what you have to do? Beta, just further simplify, my dear. So, you can write coefficient of viscosity. This is what eta beta. Yes, beta. This is what known as what eta. You can say it's a name here. So beta, this is Newton. Newton beta, you can write equation of what? Beta force. I hope all of you remember F is equals to mass into acceleration. Or I hope you also remember force F I unit Newton. Just I said. So now, beta, what is the SI unit of beta mass? SI unit of mass, student, you can say this is a kilogram. What is the SI unit of beta acceleration? So you can say meter per second square. So beta, just replace here. You can write what charge. This is kilogram meter per beta the second square. This is beta meter square into second. Now, students, you can say, sir, this second finish, meter finish. So coefficient of viscosity beta, I can write finally, this is kilogram meter to the power minus 1, second to the power minus 1. What bacha? Kilogram meter to the power minus 1, second to the power bacha party minus 1, right? Okay, now beta, I can say for next, my dear, I wanted to find what is the dimensional formula. What, my dear, what is the dimensional formula of beta coefficient of viscosity? Beta, God bless you, student, for your reaction. Now, beta party, you can say, this is beta, just now we finished here. So beta you can keep in the bracket. This is what, my dear? You can say M1, L minus 1, and T minus 1. Student can't imagine here. Student, they ask multiple time. Student, they already asked beta in MCQ, or I can say beta in PYQs multiple time here. What is the SI unit of coefficient of viscosity? Kilogram meter to the power minus 1, second to the power minus 1. What is the dimensional formula of viscosity? You can say m to the power minus 1, L to the power minus 1, and T to the power minus 1, my dear. Okay, fine. Now, bacha, sometime here, you can also use beta some alternate unit. What bacha party? Some alternate unit. That is bacha, you can say Poiseuille. You can also use bacha, this is what we found just now, Newton. Wait, does it tell me? Uh, Newton second per meter square. Students, Newton second per meter square beta. You can also say Poiseuille. Beta, this is what is the SI unit of Newton? Beta, coefficient of viscosity. You can also say this. Students, sometime in the numerical, they use multiple time Poiseuille. They use student multiple time wisely, right? So here beta I'll give here a few basics point about wisely and poise, right? So beta, what is the, you can see bacha, one what is the CGS unit? Student, what is the CGS unit of students coefficient of beta G, coefficient of viscosity, coefficient of viscosity, which is equals to what, my dear? Which is equals to poise, which is equals to what, my dear? Which is equals to poise. Poise. Okay. No, beta, everyone know, yeah. Conversion. SI to CGS. What, my dear? SI to CGS. So, beta, here again you can say Poiseuille is what? SI unit of coefficient of viscosity. So, you can write, my dear, one Poiseuille student, one Poiseuille is equals to 10 poise. One Poiseuille is equals to what, my dear? One Poiseuille, which is equals to 10 poise. One Poiseuille is equals to what, my dear? You can see this is what basically 10 poise. Okay, now, bacha, you can also say bacha in alternate way. This all thing beta, this I'm going to give you just because of numerical. Beta, you can say one poise. This is one poise here. POI. Yes, beta. POISE. Yes, beta. But I wanted to write it once more time. This is this is poise. So beta, you can say for one poise. Beta say for one poise. You can say beta. This is 0.1 Pascal second. Beta, yeah, Newton per meter square. What we can see Pascal. So beta, just be clever during paper hall. Beta. They can ask anything. They can ask. They have the freedom. They can ask. Student, next you can beta, remember one poise. One poise beta, you can say 100 centipoise. This is what, my dear? 100 centipoise. Just I'm giving you a step only because of numerical. Multiple time they use this much only. Beta जी multiple time बच्चा जी they use beta this much only here, so you can keep in your mind. Okay, you can also say बच्चा one poise. Student, one poise you can also say this is one dian second per beta जी centimeter square. Everything here, yes, you can connect from here बच्चा. My dear, you can connect from here बच्चा. One poise. Next student, you can also say one poise is equals to 0.1 kilogram meter, kilogram per meter beta. Just now we finished here. Kilogram per meter into beta second. Just everything beta, just I said. Okay, so these are the beta which I point gave you because of numerical my dear only. Yes, beta. This is what beta I can say because of numerical only. Okay. Beta after that beta some time here they can also means they will give you. No need to worry about that. Now beta, this is what is the interesting point which is mentioned in our syllabus. Student, what is the effect of I'll discuss separately. What is the effect of temperature on viscosity? And what is the effect of pressure on viscosity? These two parameters, beta, I want you to discuss. Let's, beta, try to understand first. Effect of temperature, students. I want you to discuss effect, effect of temperature, effect of temperature on student, effect of temperature on viscosity. Beta effect of temperature on viscosity. Yes, beta ji. Effect of temperature on viscosity. Acha, which increases in pressure, the viscosity. Beta, there are 2 points. I'll discuss all points by point. Viscosity of pressure, viscosity of temperature, right? So this is the point. Beta, first I wanted to discuss about I can say effect of what? You can say temperature, effect of temperature on beta viscosity. So beta, understand, listen carefully everyone. The in case of liquids, what my dear, in case of liquids, coefficient of viscosity decreases, which increases what? Temperature. I'll write here for liquids. Beta is for liquids. If students you are increasing temperature, then what you can say coefficient of viscosity beta decreases. In a liquid, in the case of liquid, coefficient of viscosity decreases, which increases what? Temperature, as the cohesive forces decreases with increases of temperature beta. What, why? So you can ask, sir, why? What's the logic? What is the logic? If you are increasing the temperature, then what coefficient of viscosity decreases? Because of what bit I can see? Cohesive force decreases with increases temperature. Beta just here you can write what's that temperature increases. You can beta put arrow mark. Viscosity increases and viscosity why increases? What is the cause? So you can say what's a cohesive force decreases. Why beta? Why this is a decreases? Because can say because cohesive force. Beta G, because cohesive forces decreases with increase of temperature. Because cohesive forces student decreases with increases increases temperature. Yes, beta. Yes, beta. So effect of beta temperatures. Keep in your mind, my dear. Hare Krishna, my dear student. Effect of temperature on viscosity, my dear. Uh, if you are increasing temperature for liquid, I'm talking, my dear. Coefficient of viscosity decreases because of cohesive forces decreases which increases temperature. This is bacha party for liquid, I said. Okay, beta we can also take in consideration for gases. What my dear? For gases. What my dear? For gases. In case of gases, coefficient of viscosity increases. What bacha? In case of gases, coefficient of viscosity increases with increases temperature. Beta, if you are increasing temperature, If you are increasing temperature, what you can say gas. If you are increasing temperature, student, if you are increasing temperature in a gas, then beta what you can say coefficient of viscosity also increases. Coefficient of viscosity also increases because number of collision between the molecule of gas increases. Because so I wanted to write out a reason over here. What is the reason? What is the reason, my dear? Because what, my dear? Because you can see that this is what you can take consider this there. This is a chamber, closed chamber. You can take, my dear, right? This is a closed chamber. So you can take beta for consideration. This is what the chamber beta completely filled with liquid, right, my dear? Okay. Let us suppose you are you can take example like that. You are supplying heat without any external source, whatever. I don't want to tell. So now, student, for this condition, what you can say, if you are increasing temperature, then what coefficient of viscosity increases because number of collision. Because now you can say these all particles. Let us suppose as a consideration at rest, but not possible beta because no gas molecule what motion is randomly. So they are just you can say motion under the chamber in random fashion. But if you will increase temperature, student, if you are supplying heat to a you can say this cylinder, so beta for this condition, what you can say it has a number of collision between the molecule gas increases. Number of if you are increasing temperature, coefficient of viscosity increases because number of collisions between the molecule of gas increases. That's all. So but I'm writing with the reason over here because बच्चा जी number of beta जी number of collisions बच्चा जी number of collisions between the between the molecules between the molecules of the gas increases. What, my dear? This is what increases, right? Okay. Now, Beta, after this year, I can tell this is beta effect of temperature on a viscosity. Now, Beta, I wanted to discuss effect of pressure on a viscosity. So, take snapshot, Beta Z. I wanted to turn the page. Okay, I hope all of you taken. Now, Beta, have a look here. Next concept. So, what is my dear next concept here? Effect of pressure on viscosity. Then, effect of pressure on viscosity. Different effect of pressure on viscosity. Okay, fine. Bacha ji, for this condition, again, beta, I'll take a one-time example of beta liquid and then beta what I can say gas. Let us first I wanted to discuss about for liquids. What bacha party for liquids? Now, beta, listen. Student, for liquids, the value of coefficient of viscosity increases with increases of pressure above 33 degrees Celsius. There is better condition which you can keep in mind. For liquids, the value of coefficient of viscosity increases with increases of pressure above 30 degrees Celsius. The viscosity of water increases with the pressure and that below this temperature initially pressure effect is negative, right, Mr. Pate? So usually this is the point what you can keep in your mind because there is a condition if your temperature rising pressure if you're increasing the pressure of a liquid more than 33 degrees Celsius, for that condition you can take which what pressure will increase, right? Or I can say also say if temperature below this temperature beta initially, so pressure effect is what? Negative. Pressure effect is what, my dear? You can take negative. Okay. So, bacha here, no, there is one more condition I can tell about liquids in a pressure. Bacha ji, liquid pressure you can also take for consideration. Student, liquid pressure beta you can also take for consideration. Pressure increases. The molecules of forces are together, which increases the internal friction. You can beta think like that. Another way, if you are increasing pressure, students, I can say if you are increasing pressure if you are increasing pressure means liquid chamber we are talking only if you are increasing beta the pressure then what you can say the molecules are forced what beta together and which beta what increases the internal frictions and leads to what increases in viscosity. Student, again I'm repeating, pressure increases, the molecules are closer, forced closer together, which increases what internal friction and leads to what increases viscosity. So if you are increasing pressure, so what you can see better for liquid, better what you can see for liquid, coefficient of viscosity increases due to what more molecules closer to each other. Okay, now Bachapati, the viscosity of gases also increases with pressure, but no, with a very huge temperature for this condition you can take, a very huge pressure you can take. For this condition, you can say pressure will also, means you can see in the case of gas, with a coefficient of viscosity also will increase if you are what? Regularly increasing pressure, but very huge pressure. For gases, the value of coefficient of viscosity increases, which increases pressure at a low, right, beta? But at a high pressure is independent of pressure. Means you can say for liquid beta, pressure increases, coefficient of viscosity increases, or you can say for this is what for gases at low pressure. What you can say coefficient of viscosity increases the pressure at low pressure means negligible you can say. But if pressure is very high, then you can say for this condition independent of what viscosity that is remains same. But at high pressure, you can say at high pressure बच्चा जी coefficient of viscosity is what independent. For gases, just keep in your mind, don't mess up, bacha. High pressure coefficient of viscosity, what? You can say independent. Independent, bacha. This is what independent. So these are the points, bacha, which I have done. I can say effect of pressure on viscosity and effect of pressure on beta, what I can say temperature on a viscosity. These are beta, I can say point which you can keep in your mind. But after this year, I wanted to discuss, my dear, that is what next point. Viscous force in detail. What, my dear? This is already I said what is viscous force, but once here, just go through formula. What's the formula which you can keep in your mind for viscous force? Okay, so beta, what is the viscous force here? Already I said viscous force is nothing but which tries to what oppose the relative motion of a fluid. Which tries to what party oppose the relative motion of a fluid. This is what you can say here. This is basically viscous force. This is beta, what you can say viscous force, right? So, Bacha party, you can say for this condition, the yes, beta, one more point here, which I want you to add. Beta, I can say for note, NOTE note. Yes, beta. The value of coefficient of viscosity changes from liquid to liquid. Jai Sri Ram student. Jai Sri Ram, my dear. Okay, fine. Bacha ji, note beta, what is the point? Just keep in mind. The value of coefficient of viscosity changes from liquid to liquid and for an ideal liquid bacha, because in our syllabus, student, in our syllabus, बच्चा party Hare Krishna, my dear. In our syllabus, my dear, we have what? Only ideal fluid. If you remember, first class of I can see beta for fluid static. So you can tell बच्चा party. So for ideal student, for ideal fluid, beta, what is the value of coefficient of viscosity? Which is equals to zero. Which is equals to what, my dear? You can say basically zero. You can say, bacha, what? Basically zero. Okay. Now, bacha, party, after that, what I want you to discuss here. Bacha, this is the, I can say, asked by J. Yes, bacha. This is beta point asked by J multiple times, bacha, party. So, this is what you can say. No, so I'm precising more here, those points. There is a probability you will get easy. You will get questions easily here. So this is student, you can say coefficient. What much? This is student of coefficient of kinematic viscosity. This is what, my dear, coefficient of kinematic viscosity. Student coefficient of kinematic viscosity. Yes, beta. They ask multiple time here. So you can say that what is this? The ratio between coefficient of viscosity. Beta, the ratio between what? A coefficient of viscosity to beta what? Density of a liquid. It's called beta coefficient of kinematic viscosity. Again, I'm repeating. It is defined as ratio of coefficient of viscosity to what bacha? Density of liquid is what bacha? We can say coefficient of kinematic viscosity. Beta, what they asked student, they asked in JEE, find or yes, what is the SI unit? SI unit of, I'm writing beta in short here, coefficient of kinematic viscosity. Now, which are just now we finish here. I can say eta. Eta a dimension formula. That is what? Kilogram meter to the power minus 1 second to the power minus 1. बच्चा. And density beta, what is density here? I hope all of you remember kilogram per meter cube. Beta, what you can say? Kilogram per meter cube, my dear. Okay. So you can say, sir, this kilogram finished. So what you can write beta finally here? This is beta meter to the power square into beta second to the power minus 1. Now, beta, I want you to write dimensional formula. What, my dear? Uh, Dimensional formula, student. I want you to write dimensional, dimensional, dimensional formula of beta G coefficient of kinematic viscosity. Simple bachcha, you can write here. This is what beta you can say m to the power 0, then bachcha ji l to the power 2 and t to the power minus 1. So beta keep in mind student because J asked beta J keep in mind beta these two, what is the SI unit of coefficient of viscosity meter square second to the power minus 1, my dear. Dimensional formula of coefficient of kinematic viscosity meter to the power 0, L to the power 2 and T to the power minus 1. Beta, so keep in mind beta it's highly recommendation to each and every J aspirants. Now, what's party? Have a look next year. So, which I can say for this condition, uh, already I said what is the effect. Yes. Now, beta, we have to discuss. I can say, bacha, coefficient of I can say critical velocity. That is, I've discussed here coefficient of what viscosity. That is viscosity finished. Now, bacha, I wanted to discuss that is what critical velocity. Critical velocity. Before that, I wanted to discuss about, I can say, Stokes law. Stokes law, beta, it's more important, and then you can easily understand what is the critical velocity. Yes, beta. Stokes law, beta. I want you to discuss first. So this is student Stokes law. In fact, here also I'll discuss critical velocity, terminal velocity. I'll discuss all point, my dear. Okay. And now, bacha, what is the Stokes law, bacha? What stated? But I know they have taken some consideration. The student, they have taken what? Some consideration. Which kind of consideration here? They have taken what? A long tube. Student, they have taken a what? You can say long tube, right? Student, they have taken a long tube, and let us suppose they already they considered there is what liquid under the tube, which is what water only, which is what, my dear, which is what water only, right? Okay, so Vitaji, for this condition, what is the point? Vita, they dropped. What is student? Let us suppose, Vita, they dropped from here. They have taken a spherical body. So I'm also taking here a spherical body only. They dropped spherical body beta. So you can say U is equals to what? Zero. What, my dear? You can say U, which is equals to zero. What, my dear? You can say U is equals to zero. Okay. Now, students, I can say beta, I'll discuss the Stokes law, what he stated. Beta, I can see when a body moves through a fluid, the fluid in contact. Now, sir, let us suppose this is the condition of initial beta party. After some time, student, this is the final student's condition. This is what, my dear, final, which as a you can take as a consideration situation of a sphere which is dropped initially from here. When a fluid moves through a what? Which I can see when a body moves through a fluid, the fluid in contact. What is fluid? You can take in consideration fluid in what? Contact with the body is dragged with it, right? Because no, but this body wants to come in downward directions, but due to fluid friction, this is what you can say direction of viscous force. Student, viscous force always acting on a body, which is what opposite to direction of motion of a body. Opposite to what, my dear? Direction of motion of a body. Okay. Now, Bachaji, I can say, beta, for this condition, what you can say? Beta, relative motion. What a student? Relative. You can beta think like that here. Student, relative motion in fluid layers near the body due to which viscous force starts operating. What a student? Viscous force starts operating. Now, which I can say the magnitude of viscous force depends on what shape and size of the body. Now, which because viscous force, what is the dependency, student? You can say viscous force, viscous force on depends on beta. This is shape and size. Shape and size of the body. Yes, beta. Viscous force, beta, what depends on shape and size of the body. Shape and size of the body. Okay. Now, beta, I can say, okay, Hare Krishna, student. Hare Krishna, my dear. Uh, oh, God bless you, beta. Sir, can you do numerical? Yes, sir. Yes, beta. Student, I can say, my dear. Basically, beta, first I'll complete theory. Entire beta theory viscosity. Student, first I'll finish. Then after that, my dear, I'll just discuss numerical. Yes, numerical. Without numerical, how can the beta? Physics point only famous for entire market because no beta. Now I'm teaching Narayana, right? Narayana Bangalore. So beta, I can say for there I'm teaching few candidate. Why I started online with because I can connect pan India and everyone can get benefit from physics point. So due to this, bacha, I'll do definitely, bacha. God bless you, dear. Now, bacha, I can say, beta, this talks lo bacha. Okay, so come to the point. So, beta, what is the finally beta answers, which is You can write beta because it's a mathematical proof. I am not going to prove over here. Students, I can say beta, stabilize beta. Uh, just when you ready, I'll call you JR in short. Okay, so JR beta, I'm not going to prove a result. So finally, beta, I can write what is the formula of viscous force according to Stokes law. According to what is Stokes law? What my dear? This is 6 pi beta 6 pi eta r into v. What beta bati 6 pi eta r into v. Yes, beta, this is the formula. In fact, beta v is nothing here. You can say it's what vt, and which is what, my dear, known as beta terminal velocity. What beta party known as beta? You can say terminal velocity. Okay, now beta party. So now I wanted to discuss here what is the terminal velocity. What is the, my dear, terminal velocity? So this is all about beta, which I said about Stokes law. Now, student, I'm going to discuss. This is terminal. What was party? Terminal velocity. Beta, this is what? Terminal velocity. Okay. So, bacha, what is the terminal velocity here? Beta, try to understand. You know, bacha, this is what? This ball, this is sphere is what? Coming in downward direction. So, beta, just make a BD of this sphere. Students, FBD of sphere. Yes, beta. So here you can say for this condition, this is the sphere. This is what my dear sphere. So you can say because there is some mass of the block beta or a sphere. Let us suppose you can say this is what mg. Something beta go under the liquid beta and contact with liquid. So you can think about my dear upthrust force. So beta this is what once acting on a body which is always my dear in which as a beta you can take the charge. This is what in upward direction, my dear. Okay, fine. As I said, bacha, a particle is coming in downward direction, my dear. So what you can say, viscous force, beta. You can think like that. Viscous force, beta, is always acting in beta upward direction. Bacha, what you can say in upward direction. So, student, again, I'm going to repeat entire word which I said. If a spherical body of a radius r, you can take bacha. A spherical body beta, I'm considering radius r bacha ji. Sir, can you explain Bernoulli equations? Beta, I can do, my dear. Yes, beta. JR, correct answer. JR, beta, correct answer. My dear JR, beta, your answer is correct, bacha. Newton's third law of motion. Very good, bacha, body. If a spherical body of radius r is dropped in a viscous fluid, it is first accelerated. What is student? If you dropped initially, bachas, what you can say? It is first accelerated, and then it is what acceleration becomes zero. What would say initially? If you drop the sphere, so sphere got accelerated, but after some time, beta, what you can say? Acceleration goes to zero, and it attains a constant velocity, and this velocity is what known as, my dear, terminal velocity. Again, I'll repeat, bacha. If a sphere you dropped in a viscous fluid, it is first accelerated, then it is acceleration becomes zero, and it attains a constant velocity called terminal velocity. Right, bacha party? So now we can see, beta, if finally system got attained some velocity, bacha, so you can think like that entire force already they are said bacha, you can write bacha party if I'm using here equation of I can say using concept of NLM. What, my dear? Summation of f net, my dear, summation of f net, which is equals to ma. Beta z summation of f net which is equals to ma. So beta, what is f net here? This is bacha, you can say the system going in non bacha. You can take any consideration bacha party. So this is what, let us suppose I'm considering bacha, this is more force, yeah, this is a driving force bacha party. So you can write, my dear, this is mj minus beta g, this is buoyant viscous force minus bacha g, what you can say, buoyancy, which is equals to 0. Correct, 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 beta. Someone replying here, I don't know name, like Diamond Lord. Okay, okay, very good, bacha. Very good, bacha, buddy. Very good, yeah. I'm very happy to see this kind of candidate in live session. Literally, I'm feeling more energy, bacha. I'm feeling proud to see this kind of candidate in the live session. Now, bacha, you can say this is bacha ji MG, which is equals to bacha. Beta, God bless you. Stay blessed, beta. Uh, Split beta, physics fund bacha among friends and family bacha, so that maximum candidate can get benefit beta ji of physics mind. Okay, so beta, this is what MG is equals to bacha FV plus. You can say bacha, this is what FB, right, bacha, buddy? Okay. Bacha, FB are just beta. I wanted to calculate here. MG, bacha, what I can say, bacha? This is nothing but beta. You have to write in terms of density, bacha. So here, bacha, I'm just considering two assumption, bacha, party. Okay, bacha, let us suppose beta here sigma is what density of liquid. Students, sigma is what density of liquid. Students, rho. Rho is what, bacha, the density of beta. I'm considering rho is what, my dear? Rho is the density of beta. I can say for sphere, right, my dear? So this is beta. I'll write here beta. What is mass? Student, I'm using here result here. Mass is what, beta? Density into volume. Mass is what, my dear? Density into volume. Correct, correct, correct. Very good, my dear. Beta, can you write your name, beta, so that I can call you by your name, beta? Student, can you write your name, beta, so that I can call you, beta, by your name? So this is rho, beta, beta, and this is spherical body, beta. So what you can say, this is 4 by 3 pi RQ into which is G, which is equals to, my dear, viscous force. Just now we calculated what's body. So this is what you can say 6 pi beta eta is what coefficient of viscosity, and R is what beta. You can take R everywhere. It remains simple, capital R only. And this is what you can write, my dear, terminal velocity plus buoyancy force. Beta, I wanted to write a expression of buoyancy force over here only, bacha. So this is what you can say sigma V into G. Beta, V remains in there because entire body under the water. So we can tell, my dear, buoyancy force, which is equals to beta sigma. And what's the beta V? This is, you can write, my dear, 4 by 3 DLU. Okay, DL. Got it, bacha. 4 by 3 beta z pi RQ into beta. This is what z. So you can see, beta, this is what buoyancy force. So beta, you can write beta buoyancy force beta as usual. This is what, my dear, sigma into beta 4 by 3 beta z pi RQ into z. Finish, beta. Beta, what we wish to find? We wish to find, beta, what is the value of terminal velocity, beta. So just apply a little mathematics. Yes, beta. Just I'll make separation here. In fact, beta, I'm going to turn on next page here. Beta, just take screenshot, my dear. I wanted to move beta next page. Yes, I hope you have taken. Yes, beta. So this is beta mg force. What I wrote already. This is rho 4 by 3 pi RQ into G mg बचा बाटे, which is viscous force 6 pi eta R into terminal velocity बचा बाटे plus 1c force sigma 4 by 3 pi RQ into G. Yes, beta. Just beta separate in that terms, my dear. So beta, this terms I'm keeping out this side, beta, left side. So you can see this is rho 4 by 3 pi RQ G minus Bajabati sigma 4 by 3 pi RQ G is equals to bacha 6 pi eta R VT. Beta DL and Hare Krishna, my dear. How are you? Okay. Bacha DL, Aditya Krishna, JR. Beta said, tell bacha, which terms I have to say, just do cancelling each other. Which terms beta I have to just do cancelling each other, bacha. Can you say this pie finished? Then बच्चा what you can say? Sir, these are finished. Maybe you got it, everyone. Sir, can you give any tips for tomorrow exam? Yes, I'll give end of the class. Yes, I'll give you bacha end of the class, my dear. Okay, so just put a right here, everyone here only. But I can take here 4 by 3 pi r square common into g. Students, you can take 4 by 3 pi r square into g, but take it out. This is what you can see, density of liquid minus density of body. What I have taken here? Oh, correct only. Density of body minus what? Density of liquid into what party? This is what you can say 6 times eta into Vt. Now bacha, just 2 here. You can say 2 to the 4 and 2 3 the 6, 3 3 the 9 bacha party. So you can say what is the terminal velocity? This is 2 upon 9 bacha pi r square g. This is root. This is what density of body I'm writing bacha party. Density of beta, you can say density of body minus the density of liquid. I can say those the student already means they are already participated JEE means, but I know SDL beta tomorrow paper I'll give it a few question I'll leak few question deal with I'll leak beta tomorrow exam. Okay, now bacha, Vt beta what? 2 upon 9 pi r square g bacha. Density of body minus what density of beta, I can say liquid bacha body. No, what is beta J2026? J beta J2026 asked beta two times. Yes, beta J. Only formula. Asked beta only formula two times. Directly bacha body. Right, only formula. If you remember the formula, bacha, then you can answer the questions here. So, bacha I can say for this condition, my dear, this is what bacha simply beta, we remember here this condition. Terminal velocity what? Directly proportional to radius square. Beta, this will help you a lot, my dear. Beta, this will help you beta a lot, my dear. Right. So, beta, this question also asked beta already multiple times. Expression directly. But as I remember, bacha, they asked J main multiple time direct formula. So beta, just anyone will go to write exam April 2024. Anyone will go to write exam JEE 2024 in sessions 2. Please be remember this formula because JEE asked two times the same formula. Weight is directly proportional to R square. Weight is what, my dear? Directly proportional to R square. So just beta, we'll go through this. No, beta. One time what they asked, G, three time I can say. But yeah, two time they ask like a comparison of velocity. One body they mention, beta. Second body they are asking. And beta in fourth case, beta, they ask what is the graph of you can say terminal velocity versus time or distance. So beta party, if you remember, yeah, this is the graph, beta. What you can say. Everyone remember, yeah. Already I said in the class. So as a short trip or parabola graph. So this is what beta you can say terminal velocity beta t, and either you can take beta this side time or you can take beta the distance. Yes, beta g. So what is the graph of nature of parabola here? Tell me beta party. This is beta graph of nature of terminal velocity beta g. This is the graph of nature of this is graph of nature which are for you can say terminal velocity are. So this is the maximum velocity attained by the particle which are. So this is you can say Vt. This is my dear what you can say Vt bacha party. So this is I can say bacha point which you can keep in your mind. Now bacha I'm going to just discuss bit more thing about this. How bacha party? Listen to me. Beta. Just beta take snapshot my dear. Student take snapshot here. Okay, I hope you have taken. Now, bacha, have a look beta next. So, what is next, bacha party? Beta, this is the formula. Yeah. Just you can from here, beta. Just you can think two constant, nine constant, pi constant, something missing, bacha. This is nine eta yeah, in the formula. 9 eta बच्चा जी. So beta, if you are taking beta entire terms is constant, so you can also say beta terminal velocity what inversely proportional to what coefficient of viscosity. Greater the viscosity, smaller is the what terminal velocity. For example, you can take lead what so attains the what terminal velocity at least in beta party. So beta for numerical, I'm telling beta few points for numerical. Yes, beta. Just keep your mind with party this point here for numericals. Okay. So beta, just as I said, let us all of you know terminal velocity what directly proportional to r square. Right, beta? So here I wanted to write as they can ask what is the they will give you. Let us suppose they give one but I can say terminal velocity of one body. This is what terminal velocity of the body to bacha. So simply you can write bacha. This is what R1 upon beta Z R2 whole square. What my dear? R1 upon R2 bacha Z whole square. Okay. Beta, next question format here. No, beta, this is highly. They ask, beta, ji, they this kind of format. Beta, they ask means this is I can say concept remains same. Beta, they ask this kind of question, bacha, in beta ji electrostatics. Beta, and next one I can say bubble problem means dynamics. These all are part of fluid dynamics, my dear. Right? Okay. So which are when n identical droplets are falling down with what terminal velocity v are combined to form a big drop. Yes, beta. You can say, let us suppose, beta, there are n identical drops. Beta, God bless you, beta, for your reaction. Student, there are what? N identical drop, which is falling. Which is what beta is falling. And beta, these all beta, I can say n identical drop. What beta? You can take as a consideration n student an identical drop. Now, beta, an identical drop students to what? To form a big drop. To form beta, you can say big drop, right? An identical beta drop to form a beta party, big drop, right? Then what is the terminal velocity of big drop is? But I know this is a derivation. I can prove you, but as I remember here, velocity of bigger drop upon which party velocity initial, which is equals to what? Which I can say r squared upon r square. So beta already I said J asked this year also bacha. J asked bacha J 2026 as well. Okay. So bacha I know this is a condition beta. This is I can say connecting from here only. But beta volume here. No, what is the condition? Beta, if I can see there are n identical drop and these all n identical drop beta what forming I can see beta what big drop. So what is the quantity which is remains in? yes, correct deal बेटा correct deal बच्चा correct deal बच्चा पानी ढुलता खारा बोला very good. How beta you are performing here in the classroom look like silence only. Hmm? In lives dear बच्चा literally you are doing very good. In classroom look like silence only here. Huh? Why? DL beta. Okay. So, but I can see bacha. Volume remains same bacha party. What beta I can say volume remains same bacha. So I wanted to just give your idea about this. How it is calculated. So bacha, you can say volume initial is equals to what my dear? Volume initial, which is equals to what my dear says. This is beta. I can say volume beta initial is equals to volume beta z final. So what is initial volume here? Just I wanted to find the relation here for radius. I'll give it as a ready-made relation. So n times which sphere which you can say 4 by 3 pi small r cube is equals to beta 4 by 3 pi r cube. Now you can say bacha the 4 by 3 pi 4 by 3 pi cancel. So what is r bacha? You can say r is equals to n to the power 1 by 3 1 by 3 into which this is r. This is beta result here, which you can keep in your mind. This r value beta I can fit over there. This r value beta I can fit over there, bacha. Then we'll get student result is what? Volume or sorry, terminal velocity of big अपन बेटा initial is equals to what बच्चा पार्टी r already we calculated बच्चा so n to the power 2 by 3 simple है बच्चा because r beta this is what you can say r square here so this is you can say beta g r square upon r square so this is cancel बच्चा so volume I can say again I'm calling volume here it's my bad terminal velocity beta I can say for big drop is equals to initial times of what n to the power beta g 2 by 3 yes beta g literally it's highly important Hare Krishna my dear so bacha I can say just keep in your mind everyone these formulas what is the terminal velocity if we have an identical drop literally I will get this question 100% no doubt at all anyone will go to write JEE means 20 I can say bacha party 2 6 seconds and definitely those candidate will get this question definitely beta I can see those candidate definitely will get this question here so terminal velocity big is what you can say initial terminal velocity into n times of what 2 to the power beta you can say n to the power 2 by 3 bacha okay, now beta, this one thing beta again you can connect. Beta, two spherical bodies having same masses. Let us suppose M1 and M2 means different masses there. I can say. Let us beta, I can say we have a two spherical body. You can say which there is two two spherical body. You can say bacha, I'm calling this is masses. One body is M1 bacha. Take different here. This is what M2, right? Beta, we used to find ratio. Falling what? You can see viscous medium beta. So we have to find what ratio of this. So beta simply here you can say according to previous result which are V1 by V2 is equal to what was party? M1 by M2 to the power which are this is what 2 by 3. Why sir? Why you wrote? Because you know your volume remains constant my dear. Volume remains constant, bacha. So, beta, you can write as usual. Okay, Barias. Oh, Bariya Singh, you joined. Very good. I'm very happy to see my dear. Okay, your friend also available here today, and he is responding very good. Your friend responding here literally very good. In classroom, I don't know what happened with him. Hare Krishna, my dear. Okay. V1 by V2 beta what we can say M1 by M2 here 2 to the power beta what you can say beta entire to the power 2 by 3 beta I know these questions here I didn't see I can say in latest right so bacha just keep in mind here what's the point bacha about you can say a small sphere of radius r you can take it as a consideration and it's a true here it's a true my dear DL only DL present here today huh beta this is what you can say r this R chapati. You can take it as a consideration here. This is what falling under the liquid. This is what which I can say falling under the liquid. Right, my dear? Okay, fine. Now, bacha, I can say if this is beta falling under the liquid here, then bacha, I can say small sphere of radius r, as I said, beta from rest. Beta, you just let's say in consideration. This is what you dropped means u zero only. So, but I can say as a result here, some heat, beta, definitely. You can say, bacha, what some heat, bacha, what finally, if this liquid, this drop, beta, finally hits the floor, bacha. So, what you can say, then what some velocity, what transfer, bacha, in terms of what you can see heat generation, bacha. So, you can see, beta, for this condition, as a result of Q, heat is produced in the viscous force. The rate of production of heat when the sphere attains a what? Terminal velocity is proportional to what? Rate of heat of production here. So beta rate of heat dq by dt beta you can write directly proportional to this is what what's the party viscous force into bacha this is the terminal velocity this is what, my dear? Terminal velocity dq by dt. Because you drop here, initial particle has an initial velocity zero. But if particle attained some amount of velocity, so finally, beta, you can see some heat generation you can take. But no, it's negligible here. But they can ask. what is the heat rate? A smaller sphere of radius r falls from a rest in a viscous liquid. As a result, heat Q is produced due to viscous force. So we can see the rate of heat production when the sphere attains terminal velocity is proportional to what? Rate of heat, which I can say terminal velocity which I party dq by dt FV into what? You can say VTR. Just now, beta, but yeah, I said the FV is what? 6 pi eta R into VT. 6 pi eta R. Sir, it's negligible. Ah, yes. S beta, S beta. Can you please give me tips? Ah, I said I'll give you, na. Wait, wait, bacha, I'll give you, yaar. Literally, if all of you liking here, literally physics point streaming here session, please like video here. Show your reaction, bacha. Show your energy, bacha party. Yes. So dq by dt bacha 6 pi eta r into v bacha. Bacha, sir, entire terms is constant. 6 pi eta beta. What you can say remains constant bacha party. So what you can say beta for this condition? This is dq by dt, which is directly proportional to what? Radius of the body, and this is what it is, terminal velocity. Literally, yeah, if you are enjoying session of this point here, so at least like video here, like session bacha party, next can get benefit of your likes, of your reaction bacha. Okay, so beta R into what beta? You can see VTR. So just now beta we finished here. Beta ji, just now I finished bacha party. This is what VT bacha and VT one more over there. So you can see this is what VT square. So this is what VT square. Beta, this question asked by J. Student, this question asked by J, my dear. This is dq by dt, which is what? Directly proportional to r to the power 5. And I'm telling you everyone, you will get this question 100% next week. Which I say you will get each and every question. Which I taught you, you will get with each and every question here. Student, take snapshot here. I wanted to turn the page. Student, take snapshot, my dear. I wanted to turn the page. I hope you have taken. I hope, my dear, you have taken. Right now. So this is I can see viscous force. I finished. Uh, Terminal velocity with party, coefficient of viscosity. Anything is there? No, syllabus finished. Syllabus finished with party. Okay. I lost internet connection. That's why I let real. No. JR beta. Took snapshots. Okay. JR beta, now you are lucky. Now, literally beta, you are lucky. Now I'm going to start beta. I can say beta practice session of numerical bacha. Hmm. Literally beta, you are very, very lucky bacha. Yes, I can say. Now bacha, I'm going to start your numerical based on this. Good, my bariya bacha. I'm proud on you, my dear. Okay. Numerical bacha. Numerical, I'm going to give you bacha. Stabilis bacha. JR. Okay. So what's the question bacha party? You can think here. But it's a very, but I can say standard questions. But I can say initially, I can say the question is student. Student, this is what you can take fully. Right. Fully beta, I can say this is connected through beta. I can see a metal block of area which is 0.1 meter square is connected to a, you can say which is string. There is a beta, I can say one metal block. Student, this is the metal block, right? This is the student connected through string. And beta, this is the beta, I can say thing which are connected through which I can say this block which and this is the ball. This is the ball, right? Okay. So beta mass, beta what we can take? This mass beta I can take 0.01 kilogram. Uh, Next beta G, this is beta 0.010 beta 0.010. There is a difference in the this is 0.01, 0.010. Okay, fine. Uh, Liquid film beta thickness. There is a liquid film bacha party, right? I can say I did wrong little. This is the liquid film bacha mass here only. Yes, beta, this is a liquid film. Yes, beta, this is a liquid film. Beta, thickness of the film, bacha, mention here. Thickness of the film. Thickness of film. Beta, I can take this as 0.3. Yes, that's why I changed. Yes, yes, I changed, bacha. I changed. This is a what? Another container. This is a container filled with what? You can say liquid. So, beta, I'm telling you, thickness of film. There is a film here. So this is what 0.30 mm. This is mass, bacha, but you mention here. Beta, you can say area of beta. This block is also mentioned. You can take 0.1 meter square. Okay, fine. Bacha ji, any more information? Not at all. Beta, when the release, block moves what? To the right with a constant speed, bacha. You can say block move, bacha. If you release here, if you release beta, then you can say this block beta motion with constant velocity. Beta, you can say this is, speed is what? Constant. You can take 0.085 the charge meter per second. Find the coefficient of viscosity of liquids. Find the find here I'm writing here. Find the coefficient of viscosity. Sir, can you write formula? Formula, okay. Formula with party. I'm giving you. Wait. Find the coefficient of viscosity. Yes, beta. See, beta, this is the definition beta already I gave my here. Hmm. Yes, beta. Beta, this is formula beta you can use. Coefficient beta viscous force. Na dV upon dy. Na बचा dV upon dy. Okay, good बढ़िया beta. Yes, beta. So now, student, I'm going to solve this question here. What we wish to find coefficient of viscosity. Now, students, you can say this area particle attained constant speed. So it's nothing here. They gave you informations of terminal velocity. So if particle attained terminal velocity, bacha, then what you can say everyone? Sir, particle system, entire system is at rest. Entire system is at rest. Okay. Okay, Bharya beta. Okay, Bharya beta. Very good. I'll see bacha party. So beta, I can say what entire system is at rest beta. So using concept of using beta concept of JR. Okay, JR. Very good beta JR. Okay, bacha. Using beta concept of NLM. Using beta what? Concept of a party and lum idea. Okay, good deal, beta. Good. Ah, chocolate, yes, chocolate. Applicable. Tomorrow I'll give you, don't worry. Using beta what? Concept of NLM here. So simply beta, I can say what? Bacha party FV. Beta, viscous force, beta. Viscous force is equals to what, beta? Same force, no, yeah, driving force. Bariya, I answered before you. JR. FV bacha, I can say FV beta what? Then I can JR will get chocolate only, not Bariya. JR only. JR only. Yes, beta. So this is FV beta. You can write here. This is what? Basically MG. JR, you can write your name first. Write your name first. Beta. This is FV. FV beta. Just now we finished here. This is NA beta. This is dV upon dy. No, okay, no secret. Okay, fine, beta. So this is what I can say at mg here. G beta I can take here 10. J beta 10 meter per second square. So we find beta coefficient of viscosity here. Eta and A beta mention here. You can beta put over there. Point one bacha party. dV upon dy. What is dV upon dy bacha party? Plus to mention here. How much? This is 0.085. Okay. And what is dy bacha party? What is dy you have to take here? film thickness 0.03. So you can say 0.3 into beta 10 to the power minus 3 into beta mass. This is 0.01 into beta g1 here. So I can say beta there is what? 1, 2 decimal na? Wait here. I have to solve carefully beta party. This is eta into zero point 0.1 बचा 0.085 upon beta 0.3 into 10 to the power minus 3 is equals to beta I can see one decimal here. There are two decimal 0.1 only. Okay, beta this will go up here. So you can see this is what it beta completely 85. So you can say bacha n into point beta this decimal finish here. So you can say basically coefficient of viscosity into 85 by 3 is equal to 0.1 here. So n beta you can say zero point 0.3 by 85. Whatever coming answer here, this is your answer for these questions. All of you have the same answer or different? Sir, use no, Baria, me and calculator how? हाँ बेटा tell me what's the answer was anyone? All of you beta calculated same बच्चा same your answer also same or something different? All of you have the same answer or different? I don't know yeah. This I'm telling you this answer of the questions. Yes beta. Good, 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 my dear. Good, my dear. Okay. Now, bacha, Pate, there is some points here which I wanted to tell you. That is what I can say, bacha, critical velocity here. Literally, I forgot to discuss, bacha. Next, beta, I wanted to discuss this is, bacha ji, critical velocity. So this kind of no bit I can next. I'll give you. Sir, I simplified. I got same. Correct. There, beta. No, this kind of no beta in the classroom, Baria, you have to maintain always first. Those are taking live streaming here, so you have to just respond fastly in the classroom. Yes, yes, beta. You will get a very good impact, and also you will get a very good score because here you are doing very good here. In fact, DL, I'm very happy to see DL performance. Literally, it's appreciable only. Now, let's have a look here. I can see critical velocity. So, beta, critical velocity is the what velocity beyond which is streamline flow is what gradually change to what turbulent flow. Bacha. No, you can ask, sir, what is this all kinds of flow? Bacha, basically, beta, this is the part of I can say types of flow. What bacha? This is the beta part of you can say types of flow. Bacha, there is design there. So tomorrow study are. Uh, Now, like you just focus here only. What you wanted. I'll do according to you. What do you want to tell? Critical, critical velocity is the velocity beyond which streamline flow. Student, streamline flow is gradually changed to change to what did I can say? Change to what a turbulent flow. What, my dear? This is what? Turbulent flow. Okay. So, beta, critical velocity is directly proportional to, beta, what you can say, critical velocity, bacha. This is what I'm writing. This is, I can say, beta, mathematical discussion. Student, mathematical discussion, bacha. This is what critical velocity directly proportional to beta coefficient of viscosity. Coefficient of viscosity and inversely proportional to diameter and density of liquid. D is beta diameter and beta this is what beta I can say density bacha party. Uh, JR, sir, Bariya is your student in school. Yes, yes, beta. Bariya is my student. JR, I am from Kerala watching, sir. Oh, really helpful. Beta, God bless you, JR. JR, beta, God bless you, beta. No, no, you can keep watching. Keep following, beta. BK, sir. You will get literally confidence in subject. Bariya, just tell about something here about BK, sir. Yeah? Bariya, beta. Correct, correct. Study hard. Study hard. Study hard, beta. Study hard only. Bariya, study hard. But keep secret. Keep secret. Hmm. Yes, nobody but just I can say JR, how beta JR, just I want to tell you something here. Bharia, already I said in the classroom, my one kid beta JR secured 100 percentile in JEE main 2024. Beta ji 2024 year. It's a history bacha, I can say for my entire life. Right, so we'll get everything bacha party. Just spread me beta everywhere with your parents, family, so that your maximum can get benefit of I can say entire explanation bacha party over physics here. But yeah, bacha, God bless you for bacha your valuable and kind word. Now, bacha, beta what I said, critical velocity bacha directly proportional to coefficient of viscosity beta upon what density of liquid and beta this is what you can say diameter. So, bacha, if we are getting from the student, yes, literally, yeah, or if all of you liking bacha, student, if all of you liking your session, yeah, just show reaction, bacha, like everyone video, yeah, it's highly required, bacha. Your one like and I can say, beta, reaction help a lot here for next candidate, bacha. Yes, but now, if you are removing bacha this thing, then what we have to use some suitable constant, my dear. So you can write VC is equals to R. R is nothing but it's what Reynolds number. R into beta eta. R into beta you can say what eta upon beta rho upon D. You can say bacha R into eta upon what rho beta. R is what Reynolds number beta. This is coefficient of viscosity. Rho is density and D is what about beta, rho beta, this is beta. I can say density, beta, and this is a diameter. Okay. So beta, now you can say, sir, what is the Reynolds number? Yes, beta. Jai asked beta multiple time, bacha, buddy. So beta, Reynolds number, just beta, do cross multiplier. This is what beta, rho critical velocity into D by what? Eta. This is what, my dear? R is equal to Reynolds number. R is what, my dear? This is JR beta Reynolds number. This is what I can say what Reynolds number. Yes, bacha. R is this is bacha ji Reynolds number. R is beta. Oh, someone wrote here. Okay. Uh, yes, 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 yes. Yes, within beta, I can see 2 to 3 minutes. I'm going to terminate, bacha. JR, yes, beta. Hmm. Uh, I can say beta timing beta for live. Next time was at 10 o'clock for 12th class. JR beta, in which class you are? 12th class na beta? Because newly we are part of I can say JR. Beta J means session 1. So maybe definitely you are in 12th class. Hmm. Yes, beta. So beta R beta what you can say relaunch number bacha party. So beta also you can write here. Relaunch number bacha party. This is what ratio of student. This is inertial force means inertia force beta upon बचा party viscous force beta what you can say this is what viscous force right bacha party so these are the point bacha party something here just keep in mind for Reynolds number bacha because this will change beta Reynolds number depends upon what diameter of the pipe beta Reynolds number what depends on bacha Reynolds number depends on bacha what diameter of the pipe and density and what coefficient of viscosity of liquid coefficient of beta what you can say was viscosity of liquid that's a critical Reynolds number, which I can say If RE, this is a point which you can keep in your mind. Hmm. No, 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 beta. I can say beta. Last few days, few students in the night joined 12th class. I can say Aryan Misra from LN Lucknow. Beta, I can say Sriyansh LN Kota. Beta, I can say yesterday night also there is Manish from Maharashtra, Pune. One boy I can say last 1 day from UP. I can say Bijnor. I forget the name. So Pan India, I'm getting here every day, maximum student bacha, not only Narayana. No, 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 beta. No, bacha. I can say Pan India. Pan India bacha. Oh, very good, JR bacha. Very good, JR bacha. So, Pan India, due to this, but I have studied here, right? So, bacha, I can say, beta, if your Reliance number, bacha, greater than RE, beta, greater than 1000. Alright, bacha, party. Then, beta, what is the beta kinds of flow you can predict, bacha? This is what you can say, beta, turbulent flow. Beta, what you can say, this is what bacha party turbulent flow. Now, bacha, you can say, bacha, like your beta 1000 to 2000, 1000 to beta, you can say this is what 2000 here. Beta, for this condition, what we can say, this is what unsteady flow. This is student unsteady flow. Right, beta. This is last bacha. You can say RE greater than beta G, we can say 2000. Right. So beta, you can say this is what implies turbulent flow already as said here. So this is beta. Also consider beta these two beta. I can say turbulent flow only. You can also say beta this is what turbulent flow. So okay, beta ji. Uh, one thing here, just answer me last questions. But I wanted to just beta. I'm in 10th studying Narayana. Okay, you are in Narayana, Kerala. Okay, very good. Just God bless you for your reaction, my dear. Okay, Bacha, just answer me here. What is the dimensions of Reynolds number? Student, just answer me, beta, Bariya, beta, JR, beta, beta, terminate your live session, Bacha. Means I'll stop the live session. What is, you can say, what are the dimensions of, what are the dimensions of beta, Reynolds number? Tell me everyone, what is the dimensions of Reynolds number? Okay, what is the answer? Bacha? Tell me quickly, fast, everyone. Tomorrow class beta only. I can say for numerical on viscosity. Tomorrow class beta only numerical on viscosity, my dear. Okay. Oh, correct, bacha. Correct, my dear. Your answer correct, literally, bacha. Okay. So, beta, answer remains same here. Which you said, bacha, party? R is equals to beta. This is what you can say rho Vd upon eta here. So, R is beta what? I can say density, bacha. You can say what? Kilogram meter to the power minus 3 beta. This is what? You can say, bacha. Terminal velocity here. This is what? You can say meter per second beta. Density beta what? You can say radius. This is what L to the power 1 means you can say this is meter bacha and this is already know kilogram meter to the power minus 1 beta and s to the power minus 1. You can say entire things what bacha party goes to 0. Correct. Yes, beta. So what you can write M0, L0 and beta T0. Yes, this is the answer. Okay, friend. Now, very good year. God bless you all. Very happy to see everyone to be part of, I can say, live session of viscosity beta. Now I'm going to terminate your meeting. Hare Krishna, everyone. All the very best.